Let's discuss a question from SFD and BMD. This is again a graphical question, so it will be fun understanding some things. Okay, now this time a loading diagram is given, and we need to uh, discuss the bending moment diagram. So the bending moment diagram, we need to figure out the correct bending moment diagram. Okay, so so facts about bending moment diagram. The slope of the bending moment diagram is the value of the shear force. Okay, bending moment is equal to the at any point is equal to the value of the shear force. So this is an interesting, this is whenever a graphical question is given, always check this slope of the bending moment diagram is the value of the shear force. So from this loading diagram I can easily understand the value, at least I can get the value of the shear force at any section, and then I can check. So let's check at the ends first, A and B. So let's start with A. At A, the slope is, what is the shear force value? At A, the shear force value is 0. Okay, let me denote the shear force with B because it's just W is just beginning here. Here, don't confuse the shear force with the load intensity. The load intensity might be maximum here, but if you start from here, the shear force value is 0. I mean, there's nothing before it. The shear force is 0. Because of the W, if you go some 1 centimeter into, then you will have a shear force develop. But at the start, it is 0. The shear force is 0. And at B, obviously, what will be the shear force? The shear force will be equal to the area of the loading diagram, and which is half base into height, is half WL. So the shear force at B will be half WL. So I'm interested in the magnitude, so I'm not writing up the signs also. So at these 2 points, you have to check which of these curves first satisfy, because the slope of the bending moment gives the value of the shear force. Now the shear force in A at this point is a finite, right? When you take the tangent, it has a finite angle with the x-axis here also. Whereas in B and D, if you take a tangent, it is 0. So the tangent is 0, it means the value of the shear force at A has to be 0, and that is true. So A and C are wrong because the shear force value, I mean the slope, the slope has to be 0 at the start, whereas they represent a finite slope. So A and C are wrong. So B and D are correct. Now B and D, now let's check the slope at B. The slope at B has to be WL by, so it's a finite slope which is represented both here and here. So only difference between B and D is now the value of the bending moment. So now let's find out the value of the bending moment here. So now, so from the slope we have eliminated A and C, B and D are the left options. So now you need to find out the bending moment value here. So let's draw a free body diagram. This is moment, and you have something like this. So this this distributed load can be represented by a single load, which value is equal to the area of the loading, which is half base into height, because it's a triangle loading, so half W into L, and it's triangle loading, so it adds 2L by 3 from the lower end, so 2L by 3. So this bending moment M will be equal, so only load is P, only UDL is the load, so P into 2L by 3 is what is the moment that comes from the distributed loading, and P is half W into L into 2L by 3, so it is WL square by 3. Okay, so the value of the bending moment is also represented correctly by B, as well as the slope is represented. B is the choice. This is how you decide in SFD VMD. You need not plot everything because the bell will ring. Thank you.